Hey guys, welcome to Digital Srini channel on YouTube, and I hope you have subscribed to this channel by now. If not, this would be a great time to do that. In the last couple of videos, we looked at various variations of unet. We looked at residual unet, for example, or unet using residual blocks, and we also talked about recurrent blocks, for unets, and of course we looked at standard unet, and we also looked at adding attention to the unet. Okay, and in fact in the last video I showed you how you can build your own, but you don't have to waste your time. If you understand someone else's code and if you think it's a good high quality code, why not use it? So I recently ran into this library called Keras unit collection, and they seem to offer in that library. I found code for unit 2D, vnet, and unet plus, and R2 unet, attention unet, and res unet, and U2net, and unet 3 plus. Again, I don't know some of these. Maybe unet 3 plus is unet plus plus plus, where you talk about these nested units. I should admit I haven't tried all of these, but in fact I tried only a couple of these, and I thought of actually making a video so you guys know about it and you can test it out and leave any comments on what you think about the library, and better yet, contribute to the library if you think that it can be evolved into something that everyone can use. Okay, so let me quickly talk about where you can find this, and then jump into a few lines of code showing how you can use this. Okay, they have good documentation, but let me just show you how I have used it on my own data set, so at least you get an idea or additional perspective from my side. This is going to be a short video, so let's go ahead and jump into the documentation. Okay, so here you go. Here is the PyPy page for this Keras unit collection. I haven't done much of anything other than just pip install. I mean, it's pretty straightforward. It did install easily, and I got access to all of these, methods when I installed this pretty easily. Okay, and going down in terms of documentation, I already showed you this screenshot of this, that they have a whole bunch of these available. But more importantly, some of these you can also use pre-trained weights, meaning where is it? Right there. So some of these backbones like unet and unet plus plus and attention unet and unet 3 plus, they have trained that on ImageNet, so you can actually start with the ImageNet trained weights rather than starting from scratch. I'm hoping that would give you much better starting point, for your segmentation. And like I said, the installation is easy. Go ahead and check the documentation. One other thing I would like to mention here is they also have code where you can import the dice or focal loss if you're interested in using any of these, or you can use your own different loss. Okay. With that knowledge, let's go ahead and jump into our code. And here is something that I have left over from my previous video, where I already talked about, hey, dice coefficient, Jacquard coefficient. Again, you can use the one from here if you would really want, right? Dice coefficient, but it's pretty easy to write these. So you can write your own if you want. Okay. And in the last video, you saw how we can define a convolution block, or how we can define a residual convolutional block right there, or attention blocks right there, right? And then we went down and we put together our own unit, our standard unit, and we put together our res unit, attention unit, where we have a standard unit during the encoder. During the decoder process, we are adding gating signals and attention blocks. So I definitely recommend going through the code that these guys actually have. I bet if I go to their homepage and look at Keras unit collection, and let's quickly look at attention unit if I can find it. Attention unit, there you go, attention unit 2D, right? So probably they have very similar structure. So you can go ahead and look at how they have defined the attention unit blocks and so on. It's very useful. Hopefully you'll find this to be intuitive. But anyway, let's get back to our code, and this is exactly what we have done the last time. And we also did attention res unit, where we used the residual convolutional block and as your block to construct your unit. But then for the upsampling or for the decoder part, we added the gating signal and attention block. Okay, so how do we do the same? Like again, when it came down to training, all we did is obviously we are importing our appropriate construct of unit and then just building the model, right? I mean, you just go ahead and import the model and compile it and then fit it. Pretty simple. Same thing with this new library. All you got to do is all this part of the code is exactly the same. Again, I'll share my code so you don't have to reinvent this. So where did it change? Obviously from the Keras unit collection, I'm importing models and losses. If you would like to use their loss, go ahead and do that. Okay. So I showed an example down here. One good thing is if you let's go ahead and import this. Oh, it's in a different, it's in a different environment. I created anytime you add something that you're not sure how it's going to affect your current environment, you create a new environment, which is what I did. But anyway, that's immaterial for now. Go ahead and do help models underscore unet, for example. It gives you all the details about how, what arguments does it actually take, okay? So I looked at that and I constructed this. So your models, this is basically your 2D unit. That's it. What does it take? My input image size, your filter numbers, which is, okay, how do you want your unit to be? It's going from 64, 128, 256, 512, and 1024, and then going back, right? So that's what this is. This is how you need to define. The way we wrote the code here, it just takes one input shape. No, not input shape. Yeah, there you go. Filter numbers, 64. And then I'm just multiplying it by 2, 4, 8. But these guys are giving a bit more control. So you can just say 64, whatever, you want to define there. So anyway, so that's what that is. And how many labels do you work with? 1 label, 2 labels, and so on. And a lot of information. So I don't want to go through, again, backbone if you would like to use VGG16. If so, what weights do you want to load? Okay, ImageNet. So it'd be interesting to start with this and then see how the training goes. Okay, so this is how you can define your 2D unit, and also for unit plus 2D, very similar inputs right there. And did I include something else? Here is your unit 2D. Where is my unit 2D? Oh, sorry, this is your attention unit 2D. Okay, so with attention layer. Okay. Again, very simple to use. That's why I think this is going to be a very short video, so you can actually see how things are, how things can be built here. And finally, R2 unit TD. 2D, the only thing I would like to show here is if you see right there, you see how you have backbone VGG16 and weights equal to ImageNet. And here I have, in this unit, I'm not using backbone, right? Backbone equals to none and weights equal to none. And when it comes down to R2 unit, you can't even mention what the backbone is and what the weights are. That's because they haven't trained this R2 unit on ImageNet weights, right? So that's why that's not available. But you can find that out when you do help models.r2 unit 2D. Okay, so I did run a few of these, and there is nothing new I learned from these. I mean, again, the same learnings from my last video. Attention res unit actually did better than attention unit, and attention unit did better than regular unit. That's it. How much better? Slightly better. But is that worth it or not? That's up to you and your application. So I just want to make sure you guys are aware of this library, and I'm giving a few examples on how to use it. Okay, I'll share the code with you. I hope you like this short video, and go ahead and like this. If you really like the content of this, don't dislike it, please. Just like it if you like it, okay? And let's meet again in the next video. Thank you very much.